Hi, welcome to our math. Today I'm doing a series of videos on radicals, and in this video I'm focusing on reducing this term. There's a fraction under a square root. I need to simplify it, pull out all the perfect squares, and make sure the denominator of my fraction ends up being rationalized, meaning no square roots are in the denominator of the fraction. Okay, so one thing you might notice is we can pull a 9 out of the numerator and denominator. Now, I don't always do that because 81 is a perfect square. And if I can leave that perfect square, that's awesome. Like with the p's, if I pull out all 4, I'll end up with an extra p. But I am going to reduce this down. I'm going to reduce a 9 from the top and bottom. I'm also going to subtract the p to the 4th. So I'm going to take this and reduce it with this. So what I'm going to end up getting is 2p over 9q cubed, and all of this is under a square root. Okay, so this numerator looks pretty simplified, but my problem is this denominator. I can pull out a 9. I can't have a square root down here. So I can think of this as being the square root of 2p over the square root of 9 times the square root of q cubed. And this is 3, which is great, but the problem is this. The square root of x is equal to x to the 1/2, which means for this to become rationalized, this exponent has to be even. To make it even, I need to multiply a q to numerator and denominator under the radical. What this will do is it'll turn this into the square root of 2pq over the square root of 9 times the square root of q to the 4th. And now we can have the square root of 2pq over 3q squared. Using this 1/2 idea, this is the same as q to the 4/2, and 4 divided by 2 is 2. If you don't really like the idea of the fractional exponents, we could have taken this and written the square root of 2pq over the square root of 9 with 4 q's. And each pair comes out once because the square root of q squared is q, and the square root of q squared is q. And we would have gotten our 3q squared through expansion. All right. I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!